So today we're going to talk about communication with technology. We use our phones and computers all the time to talk to each other. But how does it happen? How can we talk to people from so far away, and how come it goes so fast? Let's take a look at an audio signal to get a better idea. Hello world. Zooming into the first bit of it, it looks really smooth. There's a whole lot of information in there, and maybe our friend has an old phone, so we need to get rid of a lot of that information. One way to do that is to chunk it up. So we just want to define equally sized chunks and have one value for every chunk. Let's take a look and a listen at this chunking.
Hello world.
So it looks kind of like a staircase. We just need to tell them how big the chunks are and the values in every chunk, and then they'll have the signal. It sounds a bit weirder. Let's try different chunk sizes and see what happens.
Hello world. Hello world.
Alright, so we know how to make a signal smaller by chunking it up, but how do we tell the other person the value inside each chunk? We need to do it fast, so one idea is to use light. If the other person can tell us if light is there or not, then we can tell them a series of ons and offs. So as long as we can represent each value in every chunk as a series of ons and offs, we should be able to send them the signal. So we just have to convert the numbers into a system called binary, which uses just the digits 0 and 1. And then we can send each chunk one after the other through a wire, and the other person can receive the signal. Think about what the receiver might need to know to rebuild the original signal from a string of zeros and ones, or ons and offs of bits of light. Maybe the chunk size, maybe the original range. Let's take a look at a reconstructed signal. Hello world. In real life, sound is smooth and continuous. It's a wave, and we call it analog, but it needs to be digital or chunked in order for our devices to understand and send it. So it's a constant process to make these signals as small as possible while still recovering as much of the information that there was originally.